In this lecture, we are going to have a look at a class of attacks which can be categorized as network attacks because they try to overwhelm the network. We'll start with the Smurf attack. So a Smurf attack is very similar to the DNS reflection attack that we discussed previously. In the DNS reflection attack, an attacker basically spoofed the IP address of a victim and sent a flood of DNS request messages to a server. So when the server replied with the DNS reply messages, they were sent to the victim, and so the victim was overwhelmed. In the Smurf attack, the attacker basically sends a flood of ICMP ping requests using the victim's spoofed IP address. So when the server receives these messages, it replies with the ICMP reply messages, which are obviously sent to the victim because the victim's IP address was used. Now this causes the victim to get overwhelmed or crashes the victim. The way it works is this. So using a botnet perhaps, an attacker sends a flood of ICMP request messages to the server. Now the ICMP echo request message will have the victim's IP address as the source address. So this is a spoofed IP address. So naturally, when the server responds with its own flood of ping reply messages, it will send all of these to the victim. Now this causes the victim to get overwhelmed, or it can crash the victim. So this is a Smurf attack. So a Smurf attack can be considered as a variation of the reflected DNS attack but at the network layer. So the DNS protocol worked at the application layer, so the reflected DNS attack could be classified as an application layer attack, whereas the ICMP ping messages, they work at the network layer. So that's why the Smurf attack is called a network layer attack. It can cause a crash to the victim machine, and it is also sometimes difficult to detect because the IP address has been spoofed. So it's almost impossible to trace back which was the original IP which basically sent these messages, because all the source IPs in the packets, in the ICMP packets, are spoofed. Now, this is the exact reason why many of the firewalls and routers, they block ICMP traffic by default. Because ICMP pings are perhaps the easiest way to launch a denial of service attack on any server or a network. So that is the precise reason why a number of routers or domains on the internet, they block the ICMP traffic. So for internal networks, you can perhaps use anomaly detection techniques for detecting and blocking Smurf attacks. So for instance, if you know the baseline of your network, that for example, in a day you have X number of ICMP request messages, but on a particular day you see a flood of these, then maybe it can trigger a checking mechanism and you can verify, whether it's an attack or not. The next attack is the teardrop attack. The IP protocol has an interesting feature. So basically what happens is that every communication link in a network, it has a metric called the maximum transmission unit. Now this specifies the maximum size of the packet that this link can handle. Now please note, we are not talking about the number of packets, we are talking about one particular packet. So basically every link has an MTU, or a maximum transmission unit, which specifies that what is the largest size of packet that this link can handle. So sometimes what happens is that when you send a packet from source to destination, your packet may arrive at a link which has an MTU which does not accept your packet size. Now please also remember that different links in a communication network can have different MTUs, and these are sometimes imposed by the technology used for the link and so on. So what IP does is that if your packet arrives at a router and it knows that the next link does not support your packet size, what IP does is that it fragments the packet into multiple packets, and it includes the information for reassembling them at the destination. So now these two packets independently travel to the destination where they are combined back again based on the information that is inserted into these fragments. So in the teardrop attack, the attacker tries to exploit this fragmentation mechanism of the IP protocol. And basically what it does is that it basically fragments the packets incorrectly and inserts incorrect information for offsets and fragment sizes, with the hope that when the victim tries to reassemble these fragments based on the wrong information, it may cause the victim to crash. It should be noted that teardrop is a relatively old attack. It used to affect old operating systems such as Windows 95 and NT. And if you have those operating systems in your organization, which you shouldn't have in the first place, at least keep them patched. With the modern operating systems, the modern implementations of the protocol stacks, they've already solved this problem, and IP protocol simply discards such packets. That concludes our lecture. I'll see you in the next lecture.